Welcome back everybody. Today we are doing the third and final video on arithmetic sequences. In the next video we're going to look at a new type of sequence. We're going to look at geometric sequences. If you're joining us for the first time, stay with us. In this video we will do one last example of arithmetic sequences. If you are able to follow, then it means you understand the topic. But if you get stuck, my advice is that you go back and you watch the two previous videos where we did arithmetic sequences. We introduced them and we did other examples. That'll help you understand, and you'll then be able to follow what we're going to do in this example. Let's get right into our last example of arithmetic sequences. Because we called the last example, example 1, we will call this example, example 2. And example 2 looks like this. 7 over 3, 17 over 6. Then the next term is 10 over 3. The next term is 23 over 6. And the last term that we will write down, even though the sequence continues further, is 13 over 3. We're now going to solve questions pertaining to this arithmetic sequence. Before we get started on asking ourselves questions, let's just remind ourselves on the general term for arithmetic sequences. The general term for an arithmetic sequence looks like this. Tn, which represents the term number or the term that you're looking at, is equal to a, the initial or the first term, plus n minus 1. N is the term number. It starts from 1, 2, 3 and goes on, and it is always positive and it is always a whole number. And then the last part of the general term is d, which is the common difference, because for arithmetic sequences we add in order to find the next term. And what we add is the common difference. Now that we have the general term, let's get started on solving questions. The first question that we will ask ourselves for this arithmetic sequence is, what is the first term? Just looking at the general term, what's the first term a of this arithmetic sequence? And in order to find the first term, you simply go back and you read it off your arithmetic sequence. The first term that we're looking at for the sequence is 7 over 3. So a is equal to 7 over 3. The next question we will answer for the arithmetic sequence is, what is the common difference d? We've solved for a in the general term. We're now looking for d as part of the general term. And to solve for d, what we need to do is we look at the arithmetic sequence and we need to pick a term that we are currently working with. We can't pick the first term, so you can pick any of these terms. Pick perhaps the second term, and what we'll do is we need to subtract the previous term from the current term which we've selected in order to find the common difference. So let's get started. To find the common difference, we're going to say 17 over 6 minus 7 over 3. The difference between these two numbers is what we call the common difference of an arithmetic sequence. In order to add and multiply fractions, you need to find the lowest common denominator of the terms that are in the denominator, and to find this denominator, you use the multiples of these terms. So let's begin by looking at the multiples of 6. 6 times 1 is 6, 6 times 2 is 12, and we would go on and on further. Let's now look at 3. 3 times 1 is 3. 3 times 2 is 6. So this would be our lowest common denominator, 6. And what we're going to do is we're going to turn this fraction over here into a fraction over 6. And how we do that, we've already said 3 times 2 will give us 6. We'll multiply the denominator times 2. And in order to preserve the fraction as the actual number that it is, we multiply both the denominator and the numerator. So we also have to multiply the 7 by 2. This fraction will then become 17 minus 6 minus 7 times 2, which is 14, 3 times 2, which is 6. Now that we have the lowest common denominator, we can add or subtract the numerators of this fraction. And what we simply do, the denominator will not change. 17 minus 14 is equal to 3. We've got 3 and 6. We know that 6 is a multiple of 3, so we can actually divide this further, and we can divide by 3 in order to simplify the expression, and we end up with 1 over 2 as the final answer. From these two numbers, it seems that our common difference is 1 over 2. Let's pick another set of terms and let's confirm the answer that we got. So we'll use 23 over 6 as the current term. The previous term becomes 10 over 3. And so to determine the common difference, we say 23 over 6 minus 10 over 3. Like in the previous example, we've got denominators of 6 and 3. And what we're going to do is we're just going to multiply this denominator and the numerator by 2. That's going to turn our fractions so that we have the same common denominator between them. And the equation becomes 23 over 6 minus 10 times 2 is 20 over 6. And in the end we get 3 over 6. The denominator stays the same, which when you simplify becomes 1 over 2. So from what we've done, it would seem we've confirmed that the common difference, D, is equal to 1 over 2. The third question that we will then answer, now that we have all the elements that would contribute to this side of the equation of our general term, is what is the general term of this particular sequence that we're looking at. To derive the general term, we simply substitute in D and A, which we have all solved for, into the equation for general term of an arithmetic sequence. So in the end, our answer will look like this. Tn for the sequence that we're looking at is equal to 7 over 3 plus n minus 1 times 1 over 2, which was our common difference. Now that we have the general term, we can determine any term that belongs in this sequence. Let's do that for question 4. Question 4 of this example is what is term number 7? We wrote down 1, 2, 3, 4, 5. We didn't write down term 6 or term 7. So let's determine term 7 of this arithmetic sequence. And to do that, we're going to use the general term. I will rewrite it here. Tn is equal to 7 over 3 plus n minus 1 times 1 over 2. We know that n is equal to 7 for the term that we are trying to solve for, but we don't know the actual number, which is what we would solve for over here. So in order to determine the 7th term of this sequence, what we do is we substitute 7 anywhere we see n. So this equation will become Tn is equal to 7 over 3 plus 7 minus 1 times 1 over 2. So this equation will then become 7 over 3 plus, bracket simplification, 7 minus 1 is 6 times 1 over 2. Okay, the equation then becomes T7 is equal to 7 over 3. 6 times 1 over 2 is equal to plus 6 over 2. 6 over 2 can be simplified into 3. So we continue solving. We say 7 over 3 plus 3. We're now adding a whole number to a fraction. There's multiple ways to do this. But again, essentially we have two different denominators because a whole number is equal to itself divided by 1. So what we're going to need is the lowest common denominator. The lowest common denominator that we can have is 3. So we're going to have to multiply this by 3. And in order to preserve the number, we're going to have to multiply the numerator as well by 3. So the equation then becomes 7 over 3 plus 3 times 3 is 9 over 1 times 3 is 3. We now have them to the lowest common denominator, so we can solve. T7 is equal to 7 plus 9, that's equal to 16 over 3. We've now solved for the 7th term of this arithmetic sequence. The next question we will solve is question 5, and the question is which term number is equal to 25 over 3. In the previous question, we had tx. We had the number, it was 7. In this question, however, we have the final answer, which was the 16 over 3 in the previous question. So now what we're solving for is we're looking for the n. To solve this question, we'll again start by rewriting the general term. Tn is equal to 7 over 3 plus n minus 1 times 1 over 2. Don't get tired of rewriting the general term, guys. It's the key to solving all questions associated with a particular type of sequence. In this question, we have the final answer. We're now looking for n, so the general term will be rewritten and it'll now look like this. 25 over 3 is equal to 7 over 3 plus n minus 1 times 1 over 2. Because we're solving for n, we're going to start by removing the 7 over 3. We're going to subtract it from this side of the equation. Because we're working with equations, we must subtract it from the other side of the equation as well. On this side, it's going to cancel out. On this side, we have a common denominator. So we very simply get into subtracting the numerators. 25 minus 7 is equal to 18 over 3 should equal to n minus 1 times 1 over 2. 18 divided by 3 is equal to 6. So this equation would then be 6 is equal to n minus 1 times 1 over 2. Because we're solving for n, we'll try and get rid of this 1 over 2. And to do that, we simply multiply by 2 on both sides of the equation. On this side of the equation, the 2's are going to cancel out. On the side of the equation, they're going to multiply. This equation then becomes 6 times 2, 12 is equal to n minus 1. We're solving for n, so we're going to add 1 on this side of the equation. We'll also add 1 on this side of the equation. In the end, we get 13 is equal to n. So therefore, the term 25 over 3 is equal to term number 13. The last question we will solve for this arithmetic sequence is similar to the question that we just solved, but we're testing for understanding of the restrictions associated with n. So the question is, does the term 67 over 6 belong in this sequence? Again, we have a final answer and we know the general term, so we're going to rewrite it. Tn is equal to 7 over 3 plus n minus 1 is 1 over 2. We know the final answer and we're solving for n, so this equation then becomes 67 over 6 should equal to 7 over 3 plus n minus 1 times 1 over 2. We'll first get rid of the 7 over 3 minus 7 over 3 on this side of the equation minus 7 over 3 on that side of the equation. The denominators are different and we know how to convert a denominator of 3 into a denominator of 6. We did it before, times 2 times 2, so this becomes 14 over 6. The question then becomes 67 minus 14 is equal to 53 over 6 should equal to n minus 1 times 1 over 2. We get rid of the 2 times 2 on both sides of the equation, times 2 on this side. 53 times 2 is equal to 106 over 6 should equal to n minus 1. 106 over 6, if we simplify it into an actual number, we get 17.67 should equal to n minus 1. We don't have to solve further. What we know from here is we can see that if we add 1, we're going to get 18.67. So our n will be a number that's not equal to a whole number. It's a fraction number because it's got a 0.67 to it. So that means the term 67 over 6 is not a term in the sequence 7 over 3 plus n minus 1 times 1 over 2. We've now done the last example that we will do for arithmetic sequences. I encourage you to do more examples and make sure you understand them. Join us for the next video where we will look at geometric sequences.